Hello learners, welcome back to today's class. As we had previously discussed, this is Mr. Aguk, continuing in this particular topic of statistics. And in our previous class, we discussed on the definition of statistics, and we looked at methods of presenting data. And actually what we were looking into is a frequency distribution table. So we were looking at the frequency distribution table. The frequency distribution table. And our major focus for this class is on grouped data. So that is our major focus for this class, which is a grouped data. So now, having discussed everything and the major components of a frequency distribution table, we want to have an illustration. So let me just get an illustration so that we can definitely, let's look at the illustration so that we can work on this as an example. So we are told that the height of 25 coffee shrubs in a certain farm were recorded in centimeters. The heights of 25 coffee shrubs in a certain farm were recorded in centimeters as shown below. So let me just write the data. So we have 109, we have 120, we have 114, we have 121, we have 150. Then we have 149, 149. Somebody should write this one with me. It is going to form our part of this illustration. So 125, 106, 148, 140, 109, 108, 130, 138, 142. The next one is 148, 148, 147, 107, 136, 139. Then 132, 135, 109, 116, 128. So remember, we have said these are heights in centimeters. Heights in centimeters of 25. Of 25 coffee shrubs. 25 coffee shrubs in a certain farm. So what we are requested here is that illustrate this information on a frequency distribution table using a class interval of 5. So we have been told we use class interval. We use a class interval of 5. A class interval of 5. Starting a class interval of 5, starting with 105 to 109. Good. So let's embark on this. Good. So we want to present this data. We want to present this data in a frequency distribution. We want to present this data into a frequency distribution using a class interval of 5. Yeah, remember in our previous class, I had mentioned the most common classes that we use is either a class of 5 or a class of 10. And we need to have reasonable number of classes. Assuming, let's just make an assumption, like we are students. Sometimes they fail to give us the class interval, and also they fail to give us where should we start. So how can we go about that? So as I had mentioned in our previous section, is that if you are not given which class to begin, you can always reason. You can always reason like this one. Check on your data, identify, check on your data, identify the highest observation as well as the lowest observation. So let's look at the lowest observation. In this case, I'm having 109, 106. I think 106 is the lowest. So 106 in that case is the lowest. Then let me check on the highest observation. So the highest observation I can see maybe 150. 150 looks to be the highest. Is there any data which is above 150? Seriously, no. So the range 150 minus 106. 150 minus 106. So this one definitely give us around 44. So meaning that the data has a range. Yeah, so this is what we are calling range. So the data has a range of 44. So 44 you will be arguing, because at this stage we are not discussing the complex methods of determining the class intervals, but we're just arguing that if the range is 44, if we use a class interval of 5, how many classes will be there? If we use a class interval of 10, how many classes will be there? So if we use a class interval of 5, 44 divided by 5, that is roughly 8 or 9 classes. But if we use a class interval of 10, that will be 44 divided by 10, that is roughly 4 classes. So you'll be looking at 4 classes. Should I have 4 classes or should I have 8 classes? Yeah, to make data more meaningful, instead more classes will be ideal than the less classes. So that is why we can even choose a class interval of 5 instead of 10. But if you use a class interval of 10 to this data, definitely it means you are only going to have 4 classes. So let's go back to the question. Good. So as always, when we want to prepare a frequency distribution table of a group data, the first column to introduce is called a column of class. So we introduce a column of class. After introducing a column of class, we are going to introduce what is called frequency. Yeah, so we'll be introducing a column of frequency and possibly frequency and possibly what we had mentioned previously that is called tally. So let me just have that. Let me just have that. Let me just have that. Good. We are told that we begin with 105. Actually, the first data here is 106. The reason why we are not using 106 is that we want to have an easy to manage class, an easy to manage classes, classes that you can easily work with. You know, making work easier is also one of the skills in mathematics. So we begin with 105 to 109. 105 to 109. Remember the class interval. Remember the class interval is what? The class interval is 5. I said you can do it manually. You can say 105, 106, 107, 108, 109. That is 5. 5. So the next class should now begin with 110. The next class should begin with 110. So this 110 should, using a class interval of time of 5, where should it end? I said if you know you are not good, maybe you don't understand complex formulas, just use simple things. 110, 111, 112, 113, 114. That is 5. So we just say 114. Then the next one now begins with 115. Now the trend continues. 119, 120, 124. The trend now continues. 125, 129. So 125, 129. Then we have 130, 130 to 134, 135 to 139. Remember, our highest class in this case is 150. So we have not reached the highest observation. So we'll continue until we take care of the highest observation. So 140, now to 144, 150, now to 154. No, not 150. This one is 145, sorry. 145 to 149. Then 150 to 154. Yeah, somebody is asking, why can't we stop at 149? We cannot stop at 149 because there is still there's still one data which is not taken care of. The data which is not taken care of is 150, so it will fall into the next class. So we can have this, we can have that one, and now count the frequencies. So we can have this and count the frequencies. Have that and count the frequencies. So let's begin. The same way we did with the ungrouped data is the same way we are going to work with this grouped data. So I'm going to count all those observations that are falling between 105 and 109. So we check all the observations that begins with 105 and ends with 109. Anything in between. So we're going to count anything in between. So let's start 105 up to 109. So maybe I can go column wise to make it more visible. So this is 1, 2, 3, 4, 5, 6. I think that is it. So 6. So the frequency here is 6. The frequency there is 6. So how do we tally this? We say 1, 2, 3, 4, 5. Then 6. Good. It's always good to counter check. It is always good to counter check because you can have an oversight. So it is good to counter check because there might be an oversight. There may be a data that is falling in between 109 and 105 that has never been included here. So to the best of my knowledge, we have done everything. But there's also another thing that we call counter checking at the end. So if you miss any, we will also see it as we continue. Because the guiding figure here is we have 25. Counting, I said that we can check on that. That's okay. So now we are going to 110 to 114. So all those observations that are between 110 and 114. So let's count here. None, 110 to 114, 1, 1, 1, 110 to 114, 1. Good. So here we only have one observation. Yeah, here we only have one observation. We have only one observation. 115 to 119. 115 to 119. So 115 to 119. So we can see 1. Good. So here is also 1. Good. 120 to 124. 120 to 124. 120 to 124. 120 to 124. 1. 1. 1. 2. 2. Only. So here we are only having 2. Good. 125 to 129. 125 to 129. 1. 1. 2. So here is also 2. 125 to 129 is also 2. Now 130 to 134. 130 to 134. 1. 2. Also 2. Also 2. 135. 135 to 139. 135 to 139. 135 to 139. So 1, 2, 3, 4. So here we are having 4. Good. 140 to 144. 140 to 144. 140 to 144. 1, 2. So here we are only having 2. Here we are only having 2. Then 145 to 149. 145 to 149. So 1, 2, 3, 4. Here we are having 4. So these ones were 2. These ones were 4. Good. So 150 to 159. 150 to 159. So we can see it is only 1. So here it is only 1. So we can counter check this. Yeah, it is always good that you counter check. So we can counter check. Is there any observation that is not crossed? Here all of them are crossed. Here all of them are crossed. Here we have crossed all of them. Here we have also crossed all of them. Now, because we have crossed all of the observations, the next thing we are going to look into is to add these frequencies, because whenever we are dealing with this, we need to add all the frequencies and determine the total. If the total is matching the total number of observations we are having here, because these ones were 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 by 5, that is 25. So let's come here. 6 plus 1, that is 7, 8, 10, 12, 14, 18, 20, 25, 24, and lastly 25. Good. So that is 25. And there we have our frequency distribution table. So as you have seen from this particular case, finding a frequency or getting a frequency distribution table is not a big task that should always deter a student of your caliber. This one is an easy to get question that you can easily find and work out very, very, very fast without a lot of pressure, because it doesn't need you to be a mathematics guru for you to find or for you to come up with a frequency distribution table. You have seen it's just a matter of using our 5 senses. Just use your observations, count them manually as you list. So hata wale wanafunzi wenye wanasema ati maths inakuanga ngumu, now this is yours. This one is yours because this one does not need much of logic. Provided you have known, provided you have known the class interval or the class width, you have known the first observation, you have known the last observation, so you can use the range to determine the classes you are going to have. And by that, we have made sure that presenting a data in a frequency distribution is as easy as it is. So just but a recap. Just but a recap on data and presentation. We had said that when we are doing data presentation, the first and the most important one that we begin with is representing it in tables. And a table, we said the table we are using is a frequency distribution. A table we are using is a frequency distribution table. And this table, we can use this table to represent both ungrouped and as well as grouped data. So we say that when it is ungrouped, it is very easy. It doesn't need to disturb you. But if it is grouped, it is very if it is grouped, now the only thing you need to look into, groups have what we are calling classes, and a class have a class interval. Count them manually as well as count them manually. Manually write the number of occurrences, then you tally them. Once you are done with that, we are good to go. And this is now what is called a frequency distribution table. So other methods like using charts and graphs is the next we are going to discuss here. We'll be discussing how to present data using charts and graphs. Otherwise, I hope you had enjoyed the first session. I want us to take a break so that you can also have a glass of water with you there. We can continue after the short break. All right, welcome back to Knowledge Quest. I'm your teacher, Mr. Aguk. So previously, we were discussing on how to present a data in a frequency distribution table. So I want us to move a little bit, one more step. Once we have presented our data in a frequency distribution table, what are we supposed to do next? There are a lot of things. We can still present this, still present the data into other, maybe we can use a chart, we can use a graph, we can use even any other visualization. We can make the data more attractive the way we want. Another thing we can also continue asking ourselves is that what does this information, or which information can we get from such kind of a data? So in that case, I want us to jump into one also important thing. I will pick the same data we are using. I will pick the same data we are using. So just let me just write the data here fresh. So I have the class, then I have the frequency. Let me just use F to represent the frequency. So the class is 105 to 109, 1 10 to 114. We also have 115 to 119, 120 to 124, 120, 120, 125 to 129, 130 to 134, 135 to 139, 140 to 144, 145 to 149. Then the last class was 150 to 154. Good. So let me call this column a column of class. The next column is a column of frequency. This is 6, 1, 1, 2, 2, 2, 2, 2, 2, then 4, 2, 4, 4, 2, 4, then 1. Good. So this is the data I'm going to use for my next step of analysis. So I want us to go into data analysis before we proceed with other presentation models. So let's go to analysis. So we can now wrap this because I have the data on the farthest end. I have the data on the farthest end. So this one will be my worksheet. This one will be my worksheet. So I want us to look into the part of data analysis. The part of data analysis. So this part of data analysis is one of the most important parts, and I want you to be having your calculators with you. We are going to calculate some of the figures as will be dictated. So data analysis, at this stage, we are only going to classify them into two. We're going to classify the data analysis into two. The first thing is called the measures of central tendency. Measures of central tendency. Measures of central tendency. So if you are given a data like this one, we want to get some of the measures of central tendency, like the middles of observation, the central observation, things like the mean. So the measures of central tendency, we are going to have something called the mean, or simply the average. So we are going to have the mean, or simply the average. We are going to have the mode, as well as what is called the median. So those three are the measures of central tendency. They tell us how a data is towards a central position. Then the second one, or the second category, we are going to have what we are calling the measures of spread. The measures of spread and dispersion. The measures of spread or dispersion. Here we are going to have several. The first one being something called deviation. We are going to have deviation. We are going to discuss what it is and how to calculate it. That is deviation. We are also going to have what we call the next one is variance. We'll be discussing variance. We'll be discussing standard deviation. We'll be discussing standard deviation. We will also be looking at other measures of spread, such as quartiles. We'll be having things called quartiles. We'll also be having things called percentiles, as well as some things also called what? Deciles. So we are going to understand each aspect of these measures. So as a reminder, anytime we are going to do data analysis, I had said previously that we have two types of data. There is ungrouped data and there is a grouped data. So each the approaches are going to be different. The approach towards a grouped data will be different to the approach towards a what? Ungrouped data. Together? Good. So let's begin understanding each. Let's begin understanding each. So I will start with the first one. I will start with the first one. The one we call the mean. Mean, we have said, is also known as average. The mean, we said it is also known as average. This is what you do in your daily lives. Every time, at the end of the term, you always ask, your parents will always ask you when you close schools, what did you get? You tell them, I have an A. Okay? So what is A? A is an average. Average of all the subjects that you did. That is the mean. So mean is simply the average. So how do we calculate the mean? So we say we are going to have two approaches. The approach when we are dealing with ungrouped data and the approach when we are dealing with grouped data. Together, always ask yourself that question, and I'm repeating it. And when you find I'm emphasizing that, it is because these things or these particular measures will always go hand in hand with the type of data in question. So let's look at how we calculate the mean of ungrouped data. The mean of ungrouped data. So how do we calculate the mean? So we say mean, actually there is a symbol of mean. Mean is always represented by X bar. Yeah, we write X, then we put a bar on top. That is a representation of mean. So how do we calculate the mean of ungrouped data? So mean is equals to sum. We use that particular symbol or that symbol, that Greek symbol. It is always called sigma. Some people know how to write it well. Some people also do not know how to write it. So somebody will write it this way. Whichever way, it is a sum. So it is read as sum. So sum of x. Sum of x. Remember, x in this case are the observations. So you add all the observations, then you divide by n. N in this case represent the total number of observations, i.e. x is equals to observation. X are the observations. Then n is the total number of observations. Total number of observations. Total number of observations. That is now n. So it is very simple. Like, let me give you an example. The marks scored by a student in an exam were given as follows. The marks scored in a student or scored by a student in an exam were given by follows. By the last students that scored, maybe let me say, in English, that student scored 55. In Kiswahili, that student scored 70. In mathematics, that student scored 84. In chemistry, that student scored maybe 72. In biology, that student scored 61. Then maybe let's assume that that student is doing the 5 subjects. Then you are asked what is the mean score of the student in that particular class. Now we say mean is given by the sum of all the observations. So working out this problem is very easy. Yeah. we call it something that you can just bite. Mean. Add all the observations. The observations we are having here is what? We have 55, we have 70, we have 84, we have 72, and we have 61. So we want to know what was the average score. So we simply say mean. So what is the solution in this case? So we say mean for that case is equals to, mean in that case is equals to the sum. Sum means we add. So I will take 55, I will take 70. I hope you are adding where you are. Are you? Or it's okay. 55 plus 70 plus 84 plus 72 plus 61. So we add everything. Then we divide by, that is what that formula means. Sum of x means that you add all the observations, then you divide by the total number of observations. So we are going to count how many are they? 1, 2, 3, 4, 5. Good. So we are going to divide by 5. So let's work it out. Let's work it out. So we say we are adding 55. So add with me. 55 plus 70 plus 70 plus 84 plus 84 plus 72 plus 72, then plus 61 plus 61. That gives me a total of 342. So we have 342, we divide by 5. So 342 in your calculators, when you divide by 5, what do we get? We get 68.4. So we are going to get 68.4. So 68.4 becomes the mean of that particular student in that exam. So what the student will take home as the average score for that test is 68.4. And that is how we get the mean of ungrouped data. I hope we have gotten it clear. Let me repeat. Whenever you are calculating the mean of ungrouped data, whenever you are calculating the mean of ungrouped data, the first thing you need to do is to get the sum of all the observations, then you divide by the total. Sum of all the observations, divide by the what? The total. So as a good student, we always highlight what is most important. We always highlight what is most important. So I have highlighted that formula. It is my first formula in that case. Very good. So what about ungrouped data? What about the mean of ungrouped data? Mean of ungrouped data. Mean of ungrouped data. So we can progress. Let me just wrap this one here. Okay, let me just wrap everything because I believe you have seen it. The mean of ungrouped data. So I will say ungrouped data, the mean for ungrouped data. So in this case, ungrouped data, remember we had said it is a data that is arranged into classes. For example, the one that we have arranged here. So this our data here is ungrouped data. No, sorry. This, we are done on group data. Actually, we are supposed to do group data. That's nice. That's nice. We are supposed to do group data. So a group data is the one that is arranged into classes, like this one here. Good. So how do we find the mean when a data is arranged into classes? Being arranged into classes meaning that we have a data in between. So in such case, we say mean, which is also given as x bar, is equals to mean, which is also given as x bar, is equals to sum of fx divided by sum of f. So sum of fx divided by sum of f. So what is fx? Fx means f, which is the frequency, you multiply by x. Where? Let me indicate that. Where f stand for frequency. Where f stand for frequency. And x stand for midpoint. Yes. Where f stand for frequency and x stand for midpoint. So when we say sum of fx, it means we take the frequency, we multiply by the midpoint. So if you are having a data like this one, actually we are always given the class, we are also given the frequency. So the thing that is not always provided that you are supposed to work out is the x, which is the midpoint. Midpoint in this case means that you take the upper limit or the lower limit, whichever one you want to start with, plus the upper limit. The lower limit plus the upper limit, you divide by 2. You are finding the midpoint. It is like you are finding the average. So you are finding the midpoint, or what we are calling the average. So it means we have x, so we need to get the midpoint. So we will be getting the midpoint of each and every class. So get the midpoint of each and every class. So that one leads us to a different column that we are going to introduce for this data, a column which is called x. Because we said in order to get the mean, we need to take the frequency, we multiply by the midpoint. So we need to introduce the midpoint. Once we have multiplied the frequency by the midpoint, we are going to sum. We are going to add everything. So let's work out the column of midpoint. Let's work out the column of midpoint. So midpoint of this, 105 plus 109, then we divide by 2. So let's go to our calculators. We say 105, so we say 105 plus 109 equals to 214. When we divide by 2, we get 107. So we will come here and write 107. We do the same to the next class. The next class, we have 110. So we say 110 plus 114. 114. What do we get? We get 224. 224, when we divide by 2, what do we get? 112. So this is 112. Actually, once you have done the first two, the trend will continue. So this one will become 117. Then this one become 122. This one become 127. This one become 132. This one become 137. Somebody will sing along with me. This is 142. 142, and this is 147. This is 152. So 152. So we are done with the column of x. So we need to introduce a column of fx because it is the sum of fx. It is the sum of fx, meaning that f we need to multiply by x. F we need to multiply by x. So we can do this. We can multiply this column, fill up everything. So like in this case, we are talking about 6 times 107. Let me just give you an example. 6 times 107. What is that? 642. So you will complete this one, 642. This 1 times 112, 112. 1 times 117, 117. 2 times 122, that is 244. So you do that, you complete the whole table. So continue multiplying until you complete all the column. I can see some of you, some of us are very active. We can complete them very fast. Just complete them very fast. Let's complete. 2 times 127, that is 254. 2 times 132, that is 264. 4 times 127, that is 40, that is 28. We carry 2. This is 12, 14. This is now 5. 2 times 142, that is 284. 147, that is 28. We carry 2. 16, that is 8. We carry 1, that is 5. Then this is 152. So what I want you to do, is to get the totals on both sides. Find the totals on both sides. You will be having the sum of f. We will also be having the sum of fx. So we can do that as we take a short break. So let's take a short break. We work that one out. So the total of f, this one we had already gotten it previously. We said it is 25. So we need to get the totals of fx. Total of fx, we have said, let's add this one, 442, 1111, 112, 117, 244, 254, 264, 548, 284, 588, and 152. So what we get here is 3205. Good. We have the total of f. We have the total of fx. So we can now find the mean. We said mean is the summation of fx, which in this case is 3205. 3205. We add or we divide by the sum of f. The sum of f in this case is 25. The sum of f in that case is 25. So that one is going to give us the mean. So let's get the mean. So we said 3205 divided by 25. That is 128.2. So the mean of this data is 128.2. So 128.2 is the mean of that particular data. So that is how we calculate the mean. That is how we calculate the mean. I hope we have gotten the concept on how to calculate the mean. One thing you need to know in maths is that you are supposed to always do as much practice as possible. So practice this as we will up to the next sessions of more of statistics as we continue. So thank you for watching to the end, and always be sure that KnowledgeCast will always be your source of knowledge. Thank you, and let's meet in the next class.